Hello, everyone. My name is Christine Jameson, and I will be your host for today's webinar. I am the Global Marketing Specialist at CleanCNG Compression. This webinar will run a total of 1 hour with 45 minutes of speaking and a 15-minute question period at the end. You're welcome to ask questions at any time during the webinar. To do this, simply type a question in your question bar on the side tab there. Today's speaker is William David. He has worked over 30 years as a Navy weapons technician, and he's been at CleanCNG Compression for over 9 years as a global commissioning technician. And I'll pass it over to you now, William.
Okay, so this is a operation and maintenance training. The process I'm going to take you through is actually going to show you the differences between the old style of compressor skids and what we've done to make things much easier for technicians to get in and perform their duties on these machines. So the introduction to the CleanCNG 2.0, basically I'm going to read this slide. What is the CleanCNG standard? CleanCNG standard skid tour, some operational knowledge, some maintenance knowledge, and some technical knowledge. So on this slide we see the how we bring everything together, and I do have a video version of this. Each subassembly is built in a separate cell and brought together in the final stage. The building of this machine is a note. Basically, once we put the compressor onto that skid base and the electrical motor, get everything lined up, we finish this thing up in about 12 hours. So it's actually a pretty good design for us. So we see a blank screen here, and what I want to talk about before we get there is, in this slide we'll see the final assembly of the sub-assemblies. So it's very quick, and just to be able to draw your attention to what's going on in here, we will start with an empty skid base. To this is attached the compressor motor. The heat exchanger is then attached. Then the front support framework is attached. Then comes the recovery tank assembly section. The tubing is connected between the sub-assemblies, and the roof and sides. Then all doors, hatches, and louvered sections are added to complete the build. So we'll carry on with that. So on the serviceability side, we've moved from the vent leg to this vent manifold. We've attached this to the side of the compressor, so it's easy to see, easy to work on, and basically it's a centralized drain location, so we can drain the vent manifold and the compressor if need be. And this is by opening the louver doors, so the inlet louver doors. The side of the compressor is facing you immediately as soon as you open those doors. So you don't have to get in to work on this. And you can see these louver doors are opened. And basically you can see that side of that compressor. So the vent manifold is down there in the bottom. And I believe you can see my mouse. I'll use that as a pointer. So there's your vent manifold and your oil sight glass. And these were all moved from basically the head wrenching position of trying to get in by the fuel filter or the oil filter and trying to read that thing. So things are better. Serviceability. We've this is about the PRVs, and these are all within arm's reach of the discharge side of the discharge louvers. There's a man door there that you can open up, and these things are facing you right away. You'll be able to see these things very clearly. You'll be able to get in and easily read the expiry dates, so on and so forth, and they're very easily maintained from here rather than climbing up over the compressor and various other bits of tubing and stuff in the old style of compressor. So again, this 2.0 is a much better design. Lowest vibration and noise. Okay, I'll let you guys read the slide, and then I'm going to talk some notes here. So low vibration. A Canadian $1 coin balanced on edge on the third stage bottle while in operation. The benchmark coin test, a symbol of Clean Energy Compression's quality commitment, is system operation so smooth that a $1 coin can be balanced on a 200 horsepower compressor block while operating. Clean Energy Compression sets the benchmark for exceptional quality of symbolized by the ultra-low vibration CleanCNG compressor. The Canadian $1 coin was chosen not only because of Clean Energy Compression's Canadian engineering and manufacturing, but because the coin itself is unstable. With a ratio of almost 14:1 diameter to width, 26.5 millimeters in diameter, and only 1.9 millimeters in thickness, this is similar to a United States quarter and significantly less stable than the 10:1 ratio for a €1 coin, which again has measurements of 23.5 millimeters in diameter and 2.3 millimeters in thickness. If you can balance a $1 Canadian coin on an operating 250 horsepower reciprocating compressor, you know it's been designed and manufactured to incomparable standards. So this slide is depicting the Master Control Hybrid and Motor Control Center. Basically, what we see in the picture is a setup. Off the top of my head, I don't remember which exact site this is for, but I believe it's going someplace in the U.S. This has 4 compressors at this site, and in the picture we see a Master Control Hybrid. It is the main unit. It has the HMI on it, and this will supply power for the next Motor Control Center complementary. So this is a basic unit that does not have its own control power applied to it. So the MCH will supply the power to that MCCC. The next unit in that line is an MCC, which does have a transformer in it to supply control power to it, and it will also supply that power over to the next MCCC in the line, and that makes up the four blocks we see in this photograph. Now, depending on how many compressors you have at site will determine how many of these setups you'll see. And the MCH is basically an MCP and an MCC hybrid. Okay, the MCC, Motor Control Center, is standard. We see those throughout our systems. That MCC does not have an HMI on it. So the next is MCCC, which is an MCC complementary. Complementary means it does not have its own control power. MCC or MCE is an MCC for CleanCNG Essential. MCCEC is an MCC for Essential and Complementary. Next slide is the heat exchangers setup. We've gone from a horizontal what we used to call a cooler section to a vertical stack section, and it's very easy to maintain this piece of equipment in the fact that we remove a small amount of tubing off the ends of these things and undo 4 bolts on the back of each of the sections, and we're able to slide these out and actually pick them up with overhead crane if we want. There is now being a tool developed that gives us an extension to the thing. We can slide this out and really work on it right in position if it's something that's minor like leaks or whatever. And the piece that we can slide out on this extra tool is going to be able allow us to actually pick it up and set it down on the ground somewhere to do other work if need be. In order to remove that heat exchanger panel, we're going to disconnect the bimba cylinder tubing from the louver doors, so the discharge louver doors. Then we're going to unfasten the socket head screws on the panels that surround this. These panels basically direct the airflow positively through the cooler sections. The middle heat exchanger sections, we remove only the side panels, and if we have to remove the top or lower sections of the heat exchanger, then basically all 4 panels around the opening have to be removed. So continuation of the heat exchanger section removal, there's a requirement to remove all tubing on the affected HX sections. Note the bolts on each side. I've already discussed this. And consider how the sections will be lifted. That's your only real concern here, is that we are able to pick them up and set them down. There are lifting points. If you can get some kind of overhead crane available, or again, with the development of this new tool that we're working on, basically we'll be able to slide these things out and possibly pick them up and set them down. So in the one picture there, we can see the bolts on each side that we have to remove from the back side of these. And then the top picture is depicting the one of the sections actually slid out to a point where it can almost be picked up. I think it would have to come out a couple of more inches, but anyways. Excellent. Okay, for removing the electric motor, if ever it needs to be done, and it is a rare thing, the recovery tank man door has a removable hinge side so that we can pull that motor out completely. So understand location of the fasteners, the panels, and the hinge support to remove the door support. And this is a lower section with the bolts removed near the base of the electric motor. So this is on the man door, which is on the discharge louver side of the compressor. And what we're looking at from the inside to the hinge support for that man door. So to remove the motor, you need to remove 3 panels. You remove the door that we're talking about here, take out the 4 bolts, remove the panel piece. There's a corner section. And note, for all the units there is an additional step, and that is to remove the main door hinge side corner panel. And it comes out very easily. So the fan motor Venturi alignment. This is critical in airflow through the heat exchanger. The motors, once in position, are not adjustable. And the design of the support for this is places it dead center of where that Venturi should go. The Venturi section is the section, and I will move my mouse here if you're watching, is this section that goes around the outside of the fan blades. Now, in the center picture, we see the hub is pushed onto this quite a ways, and I did that on purpose to show you that the fan blades are in the wrong position in this picture and need to be moved so that that trailing edge, follow my pointer, the trailing edge is 1/8 of an inch in from the trailing edge. So where I'm pointing is 1/8 of an inch in roughly from the back edge of the Venturi itself, and that makes sure that all of that fan is being used and that the air is not slipping off over the blade tips. And this takes to get this into position and bolted down probably takes about maximum about 20 minutes. So the main motor removal for the twin. So when we do a twin, basically they're pre-positioned on your concrete slabs and spaced about 4 inches apart, and then we can connect those together. Now, to get to the access to the motor, there's 3 hatches that we need to open, and then in order to have that same kind of access when you have a twin, the motor side is what butts up against the other compressor, so other compressor skids. So basically we need to go in through a couple of doors that get added to a twin setup. So in the first picture here we have the compressor access door. This will actually give you access from the one skid going into the other skid so that you can work on the right wing of the compressor. So once you open this door, you'll see it'll be right in front of you, the end of that compressor wing. And then down to work on the motors, basically there's 2 smaller hatches, and these hatches are okay. Anyways, what happens here is this door gets lined up with the compressor, and this is the motor, and those 2 hatches will actually allow you access to the slide base here so that you can undo it and move this motor to tension belts, to remove belts if you have to do rebuilds, so on and so forth. So this is shown on a single, and it'll be this side that actually butts up against the other skid. So they'll both be positioned exactly in the same orientation. They'll be 4 inches apart, and basically this is going to make it very easy to work on this. It beats climbing over everything. Okay. Now, I don't have a picture to show it. In addition to this, we have a beam that slides in. I'm going to just make another statement. So we looked at the hinge support that we had to remove. My apologies, people. This door has to come off, and this corner of the skid has to come off. And in behind that little panel is the actual hinge piece that supports the door that has to come out. And then we would remove all of that inlet spool, and we put in a large beam inside of here that will actually support the motor. We can pick it up and slide it right out through this door on the end. Okay, the inlet and discharge louver control mechanism. So there's an adjustment valve to control the speed of the louver basically opening. Opening and closing, so it doesn't slam and make a lot of noise and possibly cause breakage or whatever. So they put a a variable snubber, so to speak, in here. So the needle valve is acting as a snubber on this. And you can control the speed. Now, you don't want to over-adjust this. Basically, it needs to make some noise when it opens and closes. Because of the speed of closing, it may not close it completely. And we find in colder weather that if it's open at all, the inside of that compressor gets very, very cold. So the first stage discharge pipe and its support brackets, it's critical that you know about these. Coming off of the compressor block, we see tubing and a clamp. This clamp is just above the flooring in this access opening, or access corridor, as they're calling it. Basically, you remove that section of flooring and you'll be able to get this pipe spool out. And there's a breaking point between the two sections of pipe spool midway across that floor. And if we continue further and we go out to the front, or not the front, but the discharge louvers, and open those doors, we cannot physically see this next clamp. You would have to remove the lower flashing piece, which is the same stuff you would remove for the heat exchanger changeout. So just the lower piece, and then you'll be able to see this clamp inside of that opening, and it's easy access to get in here and take this apart. So if you ever have to work on that, basically that train of piping, this is how we would do it. So the twin package skid installation setup is, we don't have any pictures for this because for some reason we don't actually stick the two compressors together in the factory. And finding pictures of a twin setup this early in the 2.0 is hard to get. As soon as we get it, we're going to add it to this slideshow, and then we can talk about it. But basically the whole thing is the two compressors, again, 4 inches apart. The bridging kit actually is a roof section. We put the two side sections on. They snap into position. The only way to remove these is to actually go through that twin skid access door that gives you access to the compressor from the one side. And basically, there's some latches that you can manually trigger that you can pull this bridging kit off if need be. Once these side pieces are on, the roof section goes on. It would normally be sealed with some kind of a latex sealant, and basically keeps the whole thing watertight. This next slide is the overhead crane locks. Basically, the overhead crane accesses to all the heavy parts situated on different parts of the skid. And there are methods to lock the sections of it together. In the middle picture, you can see it locked together, and basically the trolley is able to run right over those sections. This is designed to pick up the electrical motors for the fans. The short section that we see on the bottom is over the left wing. This can be unbolted and moved over to the right side to do work on the right wing of the compressor. And then sections of this may be removed to work with a tripod or the roof bolt-on section that they are actually still in design stages of building. This is to allow you to work on the center throw to take the cylinders apart and basically move them up to the rooftop. There's going to be possibly the ability to move it out to the front side of the skid and be able to lower it right down to the ground. So there's still things being developed for this, tools to make things a lot easier for us, and we'll see those very shortly. Anyway, so these sections of this crane can be used anywhere. The crane unit for the electric motor is again totally separate, and if I go and look at this trolley down here, it's going to be a larger version of this trolley, and it's going to be able to pick up that like a 250 horsepower motor, which is a pretty good feat in itself. So as we'll move along. So in this picture, I'm trying to show the rooftop hatch. Now, alongside of that hatch is two support beams that you'll actually attach that tool they're developing to right now. And basically, we'll bolt the legs down for it, and you'll be able to. It's got a piece of that eye girder that will allow the trolley to move back and forth. And you'll be able to drop it either on the rooftop or drop it right down on the ground. So to work on that, basically remove the hatch top, remove the tubing, remove the bracing. This is the critical skid anchor point locations and skid installation requirements. So all skids are laid out exactly the same and are as follows. Around the skid, around the compressor block, we have 4 tie-down points. Let's see if I can get up here and point those out. So that's these 4. Then there's the slide bases on gets surrounded, and so the slide bases will be right over this section here for the electric motor. And then the rest of them are just basically anti-vibration tie-down points. I'd like to point out also that that vibration, that coin test that we did was done on a skid basically sitting on concrete with absolutely no tie-downs on it. And at one point they took it out into the gravel parking lot behind the factory and ran it on gravel with the same results. So that's a pretty good statement. Tying these things down is standard with our compressor installation manual. So we showed the skid tie-down points. Grouting is optional due to the fact that the skid itself is virtually no vibration. And the vibration that there is, if you tie it down, has a possibility of being amplified. You'd have to have a perfectly smooth setup, so shimming would be required probably to take that out. I can't think of anything else to say. Move along. So skid vibration measuring points. So the compressor block was the key point that was measured in the past for commissionings, and now we're going to use all of these yellow connections on the X, Y, Z axes, and we're going to measure the skid. This is going to be the basis for health monitoring of the system, and this is the intake side of the compressor skid being shown. This is the discharge view, and we have 4 corner points to measure here. So this is a cylinder sensor diagnostic port slide. We can add high-speed PTs to this for gathering data. ultra-fast reading PT that measures pressure and logs data. This can be put into a scale and looked at for fault finding, for various things, just to see how, in some cases, how the rings and piston rings and that are wearing inside of the compressor. And basically, it's an addition point. We don't have to take the cylinder apart to find out what's wrong inside. So this is something better, something. So the recovery tank isolation valve, the tube that goes out the bottom of this valve basically goes to the PRV. So this is a way we can block it and bleed it, and makes it a little safer for us to remove that PRV, or SRV in some cases. It depends on how you call it. Same job. It's a lockable valve. It locks in the open and closed position, so nobody can mess with it. Here we're doing a lockout tag on it, but I would probably use something a little more secure than that. This is the center wing support bracing installation. So examples of the support brackets, they're very robust. Basically, what I'm trying to say is that the vibration, if there is any in the compressor, is spread out over a larger area. To me, that means we're enlarging the mass, and others would say that it's just a rigid piece, makes the compressor more rigid. I think we're all right. What it does is it reduces the vibration felt immediately at the base of the compressor. So the new back pressure manifold design, instead of having tubing that went from between the two cylinders, we used to have tubing that came out the sides of these and then would get fed in the front side of the scrubber bottle. Now basically the manifold itself, what they've done is they've taken a double acting and put it on the single acting cylinder, and they're these two single acting cylinders, and they're taking that required gas for the difference in size of these two cylinders, and they're actually putting it in front of to be used, or if the larger cylinder needs more gas, then we take out of the scrubber. I'm not sure if that's confusing or not. This might be a good question. So this manifold is primarily used on the first stage. Sorry. Okay, my statement is wrong. This manifold is primarily used on the lowest stage of compression. During the compression stroke for the head end, the crank end piston has a larger volume of gas, so that needs to accommodate for that. So this is going to push the gas back and forth. Therefore, the extra gas volume is diverted into the inlet side of the lower stage cylinder. During the compression stroke on the crank end piston, the head end piston cannot supply enough gas to balance, and that is equalize the pressure for the crank end piston. Therefore, pressurized gas is drawn from the suction side of the lower stage to balance the crank end piston. This also tends to reduce the rod loading by any rod loading difference. So the pressure that's coming up from the lower stage before like the scrubber gas, if it's at 20 or 30 psi, it's obviously going to lower the rod load pressures. So this also reduces ring wear in the cylinders. Thanks for watching.